Welcome to Concrete 101. Today we're going to talk about one of the most important raw materials that we use in our concrete mix. As you know, our concrete is made up of a variety of materials including cement, water, pigment, admixtures, and aggregates, or sand and stone. So why are aggregates so important? Well, the main reason is that they make up the vast majority of our mix, up to 70 to 80% of our concrete mix by volume. This affects all the properties of the concrete and how it looks, feels, and the texture of the units. Poor or out of spec aggregates can limit the strength that we can get in our concrete products and can adversely affect the durability and service life. Finally, aggregates have a big impact on the economy of our mix and how much cement we end up using. So let's look a little closer at our aggregates. First, what are they made out of? Basically, they're mostly natural materials such as granite, limestone, or silica. Second, we can categorize them by their size, and we use two different categories. First, coarse aggregate, and the second is fine aggregate, or stone and sand. In terms of coarse aggregate, the aggregates that we use in our manufactured products are much smaller than are used in regular ready-mix concrete. And that's because our products are smaller compared to a large poured-in-place slab. Our largest coarse aggregate is about 3/8 inch in size or smaller. As far as sands, we can have a variety of sands, all the way from a normal concrete sand, which has a variety of sizes, including medium-sized particles and smaller, to something that's very fine, like a mason sand or beach sand. Besides size, the next most important property is the shape and texture of the aggregates. Again, here we have two different categories. First, natural aggregates, and the second are manufactured aggregates. Let's take a look at two different 3/8 inch stones. Here we have natural gravel, often dredged from a riverbed. Notice the round shapes. That's good for concrete flow and makes the mix easier to feed and fill molds properly. On the other hand, because the surfaces are so smooth, the particles don't interlock together well, and the cement has a harder time binding to the surfaces. This can lower compressive strength. Here we see crushed or manufactured stone. These are mined in quarries and then fed through crushers to reduce the size. Notice that the crushed aggregate has more irregular shapes with sharper edges. We also see some flat elongated pieces. Angular crushed aggregates don't flow well, which means we have to work harder to get correct fill and density. On the other hand, the rougher surfaces allow particles to interlock together, and cement can more easily bind to the aggregate surface. In this way, the compressive strength may be higher. Another important property of aggregates is their moisture absorption and related freeze-thaw durability. For aggregates with absorption values over 1%, they can absorb a lot of water. And if those aggregates are used in products that are exposed to very cold temperatures, the water can freeze. When it freezes, it expands and exerts tremendous pressure, both on the aggregate and the surrounding concrete. This can result in the whole concrete unit failing. So how do we decide how many and which aggregates to use? We have a number of considerations. First is the size of the units that we're making. If we're making large units, like large SRW segmental retaining wall units, we may use a larger coarse aggregate. If we're making smaller products, like a paver, our coarse aggregate may be a lot smaller. Also, we need to look at what are the sizes that are actually available in our area. We often blend 2 or 3 aggregates together so that overall they fit together very well and we make good concrete products. We may also choose an aggregate for its color, to be used as an accent in a split face or ground face block. The actual aggregates we choose will be dependent on the availability and cost of the options in our area. Whatever aggregates we choose, we should make sure that they're clean and contain limited amounts of very fine material, clay, and organic impurities. All of these can negatively impact the quality of the concrete and cause us to use more cement. Now that we've talked about some of the properties of aggregates, let's get a little more insight on the effect of shape from our good friend Diamond Jim. In this case, the marbles represent the natural gravel, while the dice represent the manufactured or crushed stone.
Howdy folks, this is Diamond Jim Reel here, your gambling man, and just a little bit of a gamble between you and me. How many dominoes you think are in this jar? We'll get back to that in just a minute. We're going to talk about aggregates, their size and shape. Now, size and shape matter because in concrete we want a certain texture and we need a certain strength. So the kind of aggregates that we use are going to matter a great deal. So if I use, and I'm a gambling man with dice, if I use dice-shaped aggregates, they're cubes, they tend not to roll very well, but there's a lot of places for the cement paste to grab onto it. If I'm using marble here, and a lot of people think I might have lost my marbles, I pour these out, they tend to roll really well, as you can see, and that allows concrete to flow a little better. Not so much hold as the square dice, mind you, but they still work fairly good for concrete. And these dominoes here, we'll dump some of these out. These dominoes are long and flat. They don't flow very well at all, and they tend to be a little bit weak because they're long and thin. The size matters as well, so larger aggregate takes a little less cement to glue together. Smaller particles take more cement to glue together, so just kind of keep that in mind. For those of you wanting to bet on the dominoes thing here, it's 33. You got it, 33. That's from Diamond Jim, and we'll see you next time.
So far, we've been talking about regular normal weight aggregates. By normal weight, we just mean that they are typical rocks and stones that are fairly heavy. They have bulk densities of 90 to 100 pounds per cubic foot and lower absorption values that range from less than 1% up to maybe 3 or 4%. Now, let's talk about lightweight aggregates. These aggregates are light compared to normal weight aggregates at least, and have much lower bulk densities of 40 to 60 pounds per cubic foot, and corresponding higher absorption values of 10 to over 30%. To give you an idea, a 5-gallon bucket of lightweight aggregate may weigh only 20 to 40 pounds as compared to 60 or 65 pounds for normal weight aggregates. Lightweight aggregates can occur naturally, for example in pumice, or are manufactured by putting specially mined shale, clay, or slate into a very hot rotary kiln where they blow up like popcorn. Once the particles are graded, they're ready for use in lightweight concrete block or CMU. Regular normal weight CMU typically weigh 32 to 40 pounds per block, and masons understandably get tired of lifting them all day long. So in some regions, the masons have convinced the block producers to make lighter CMU of 25 to 29 pounds per block. This speeds up installation and reduces injuries. When using lightweight aggregates, it's very important to follow some good manufacturing practices to make sure we are making high quality units. First, make sure that the aggregate is properly wetted and not dried out when we make our block. This is critical. Lightweight particles can absorb up to 30% of their weight in water. If you look at the picture, you can see why. All those voids that can store water. Dried out aggregates are like sponges that can pull water away from the cement that the cement really needs to hydrate, and we could end up with low strength, low quality block. Second, to make sure that there is sufficient water for the cement to hydrate, lightweight aggregates should be pre-wetted. Pre-wetting can be done by using a sprinkler on the aggregate pile as it sits in the yard, by spraying water on the aggregate as it moves up the feed belt up to the mixer, or by adding some extra batch mix time up front in the mixing sequence. So just aggregates and pre-wet water in the mixer before adding any other ingredients. Whichever method you use, it's important to satisfy their thirst first. There's another type of material that we sometimes use as an aggregate in our concrete production, and that is regrind. Regrind is a term that we use for recycled concrete. Sometimes units don't come out perfect, with chips, cracks, or other defects. Units that can't be sold are called culls. These are picked off the line as the units make their way to the cubing or packaging station and often thrown into dumpsters as waste. We can reuse these waste materials by grinding them down into aggregate-sized particles, which can then be fed back into another mix as aggregate. Recycling waste units back into usable aggregate is good for the environment and our companies, but there are some limitations that we need to bear in mind. First, it's often difficult to keep a consistent distribution or range of sizes in the aggregate over time. Also, as you can imagine, the regrind may have a variety of colors depending on what happened to be fed into the mix that day. Therefore, savvy producers limit the amount of regrind in their mixes. We recommend no more than 10% regrind in any aggregate blend. Also, limit regrind to standard gray block. Stay away from colored or specialty units.
So let's review what we've learned today. Aggregates are very important because they're the largest component of our concrete mix and affect everything from appearance to performance and the cost of our units. Size, shape, and texture matter, as well as particle size distribution or grading. If we get optimum grading by combining 2 or more aggregates so that it fits our target curve, we can achieve maximum density, improve performance at the lowest cost. Thanks again for spending some time with us today, and we'll see you again next time.
So that's all for today, folks, but feel free to check back with us anytime on our website, acmchem.com, where you can get more information and more videos on Concrete 101.